So, hello everyone, and thank you for coming to this seminar. This is a Licentiate seminar where Apala Ray will present a thesis named Initial Trust Establishment for Heterogeneous Industrial Communication Networks. My name is Mats Björkman, and I am Apala's main advisor, and we have two more advisors sitting over there. It's Dr. Johan Åkerberg, partly from MDH, partly from ABB, and then it's now Professor Mikael Gidlund from Mittuniversitetet, and partly ABB still, right? Yes? So apart from Apala, there are three very important persons here today. First of all, I would welcome very much our opponent, Docent Christian Rohner from Uppsala University. As you know, since about a year ago, we have a committee for these licentiate seminars. So apart from Christian, we have two more persons. It's Docent Mikael Ekström from IDT MDH, and it's Professor Sashikuma Punnikat, also from IDT MDH. So the procedure will be as follows. First, Apala will present her work. After that, we will take a very short technical break, after which we might remodel a little here, and Christian, the opponent, will start the discussion session with Apala. Yeah, the books were enough. Good. There are two more in the box with holes in them.
Yes, you can take this one.
Yes. After this, the rest of the grading committee will ask questions, and after that, the whole audience is allowed to ask any questions they would like. Then, after that, we will close this part of the event. There will be a closed meeting where the grading committee will decide on the outcome, and during which time the rest of you are welcome to wait in our coffee room over there for the outcome of this that will be announced there. So, without any further explanations, I would like to leave the floor to you, Apala.
Thank you, Mats.
So, please.
Hello, everyone. Welcome to my presentation. I am Apala, and I am going to talk about my licentiate thesis on initial trust establishment for heterogeneous industrial communication network. I work in ABB Corporate Research, and I am an industrial PhD student. My thesis has been supported by Communication Research Area in ABB and by also KKS through its UG school IDT MDH. I am privileged to have Mats Björkman, Johan Åkerberg, and Mikael Gidlund as my supervisor. Now, let me quickly present the outline of my talk. I will start by motivation of my work. I will present why I have chosen this research topic. Then I will show the research questions which I have addressed and the research methodology which I have followed. Then I will summarize the publications which are included in this thesis. Then I will give an overview of related work in this area, and next I will present the approach which I have proposed in this thesis. Then I will summarize the contributions, followed by the conclusions and the future work. Now let us see why we need a new approach to bootstrap the initial trust in industrial networks. Here is a typical industrial plant, and security is important for this industrial plant. Plant owner asks for a secure system. Now, compared to traditional information security, industrial plant has different performance and reliability requirement. Sometimes the safety and availability requirements might conflict with the secure design of plant. For instance, it is not acceptable to create a system which take additional time to set up security and as a consequence stop the production. Similarly, a system which needs authentication and authorization before any emergency action in industrial plant might not be suitable for industry. Therefore, there is a need to improve the security workflow in industrial plant so that the security can be realized in practice. Now, let us see how industrial plant works with different roles and employees. The devices which are going to be installed in the industrial plant comes from manufacturing unit, and this manufacturing unit can be a different organization than industrial plant. The device manufacturers produce the devices and the devices are shipped to the industrial plant. Now, in industrial plant there is a commissioning phase where the devices are configured before installation, and this commissioning phase can be done by this industrial plant or manufacturing unit or a third party consultant. Now, the commissioning engineers comes to the industrial plant, commission the devices and the devices are installed. Now, there are other roles involved in the industry where operators monitor the plant performance through operator portal, and if something goes bad, operators call maintenance engineer. Now, maintenance engineer comes and fixes the devices. Now, at later point of time, if we found there is a communication security breach and the plant owner is asking for a system which cannot be stopped for a longer time, the question here is how to ensure communication security. Cryptography is one of the way to ensure communication security, and there are challenges in the area of key distributions, especially in industrial plant. We will see why key distribution has challenges in industrial plant and how it is done in today's scenario. So, in cryptography there are two basic class, symmetric key based cryptography and public key based cryptography. In first scenario, we will see how key distribution happens for symmetric key cryptography in industrial plant. There will be a security management component which manages the keys which will be used for communication, and suppose there is device A and device B which needs to talk to each other. Now, in symmetric key, the key has to be shared using a secured and trusted channel. Now, in this scenario, we will assume this device A and device B are not capable of generating keys. Therefore, the key can be generated in the security manager, and now this key has to be downloaded to device A and device B through a secured channel and possibly with manual intervention. Now, if there is a commissioning device, then the key can be downloaded through commissioning devices to device B. Now, we can see here that there is a need of a secure channel to transfer symmetric key, but the real challenge is how to create a secure channel. Secure channel means except the communicating parties, no one can listen what is the message being exchanged. It is like a chicken and egg problem. If we have a secure channel, then we need some key which will encrypt the communication, but to share the keys we need a secure channel. So, generally there we use out of band communication like manual entry, where before the communication the device is configured with some parameters which will be used to bootstrap the initial trust. Now, this manual entry has their own challenges. Now, entering a 16-bit AES key which is supposed to be secret and individually to all the devices is error prone and tedious job for engineers. In addition to it, during this manual entry, the key is getting revealed to the employee who are handling these devices. Now, in asymmetric key cryptography, we do not need a secure channel. Instead, we need a trusted channel. Now, let us see how asymmetric key based key distribution is done. We will be having a security management component and with device A and device B. In the same scenario, we will assume that device A and device B are not capable of generating key pairs. Therefore, the security management component generate the key pair for device A and device B and download through a secure channel. The challenge is similar to symmetric key based key distribution. However, in asymmetric key based key distribution, this device A and device B need to share their public key through a trusted channel. Now, the requirement here is a trusted channel, and the challenge is how to create a trusted channel. Trusted channel means when two communicating parties are communicating, they are authenticated. Therefore, when device A is talking to device B, device A has to ensure that it is talking to device B, not any third party or any attacker. Now, we will see why key distribution has extra implication in industrial plant. We have seen that the device manufacturers come from manufacturing plant, which might be a different organization. Similarly, we have different commissioning engineers, and we have operators and maintenance engineer in industrial plant who handles the devices. Now, when the device is configured for key management, all secured and trusted channel are being handled by any one of those employees which are there in the plant. Therefore, if a key is leaked, we will not know from where it has initiated the problem, because the device manufacturers produce the devices. If we assume he has given some key, then later part of the time commissioning engineer or maintenance engineer, they are handling those devices. So, this imposes a challenge when the key is directly being handled by the employee, and if the employee leaves the organization because they are not permanent, the key is also getting revealed and going out of the network. Therefore, in key distribution there is a need of a starting point from where this key management can happen, and it will consider this dynamic role of environment with different employees. Therefore, in this thesis we focus on two research questions: how to efficiently bootstrap the initial trust considering this different role of employees and the entire plant life cycle, and how to manage the life cycle of security workflow for these different roles of employee for entire plant life cycle. Now, I will quickly browse through the research methodology which I have followed in this thesis. When I start my research, the security challenges in heterogeneous networks were known. So, the first part of the study was to do a literature survey and state of the art analysis. This resulted in defining the problem statement and research questions. Now, the second step of the thesis work, we assume or we had a observation that there are other industrial segment where security has been considered for a longer time. So, the problem statement what we are looking for industrial plant might has been looked in other domain, and if we can adapt or tailor some solution from other domain and can make an applicability assessment. Therefore, we did a reusability assessment with financial sectors. Now, in the third part of the research, we proposed a solution where we told how to bootstrap the trust using the employee trust parameter. Now, this concept was derived from chip and pin enabled financial card readers, where we authenticate the credit card transaction with the user's knowledge. Now, in the fourth step, we give a framework where the employee trust parameters can be verified with the help of employee management system and the security management component, and we demonstrated through a proof of concept that this workflow is feasible to implement, and we have done a security workflow analysis using Avispa tool. Finally, this initial trust bootstrapping research has been summarized, and we defined the future research work in this licentiate thesis. Now, here are the publications which are included in the thesis. Paper A gives the state of the art analysis and define the problem statement. Paper B has done the applicability assessment from the financial sector. Paper C, we give the solution to initial trust bootstrapping with employee trust, and paper D, we give the framework for initial trust establishment with implementation. Now, this thesis work in security is related to industrial automation security and key management. Now, there are a lot of research has been done in key management, and the work is still going on. And what we realized that there is no single solution which can cater all the key distribution related problem, because the requirements of the key distribution mechanism depends on performance criteria and different criteria what is applicable for the scenarios. But most of the key distribution has explicit assumption or an explicit mechanism to establish the initial parameters. Now, the explicit assumption is that the devices in the network are trusted and we can give the key directly there. And the explicit mechanism is out of band parameter sharing, where this manual entry is done and manually we enter some initial key which will be used for later part of the communication. There are other work where the authors propose to use manufacturer provided certificate and the secure device identity to bootstrap the initial trust. Now, this imposes a tight constraint on manufacturer, where the device has to build with certificates and secure device identity. In addition to it, it might increase the production cost, because the credential generation process also has to be included during the device production. Now, there is some other interesting work where the multipath signal propagation is used as a source of randomness to generate secrets, and there are some key deployment protocol where the key generation is done using the physical layer information. This provides an user friendly mechanism for key distribution, but the generating keys from the industrial channel environment needs to be verified. There is another related solution in Wi-Fi devices with push button configuration, which uses tamper evident pairing. Now, this does not need any out of band key predistribution. Instead, two devices need to press their button so that both the devices will agree on a same key which will be used for communication. Now, in my work, we take a different approach where we combine the knowledge of employee management system and the security management component. Employee management system is the same system which gives access to the employee to a plant premises. It is similar to our office or university access control system, where we get registered and get an identity card. In our work, we consider that the employee who are going to handle the devices will enroll in an employee management system and they will receive an identity card. Now, we propose to include a encrypted trust parameter in the identity card. Now, this encrypted trust parameter can only be verified by the employee management system. Even the employee will also know what is stored in the card, because it is encrypted with the employee management system's public key. Now, the device which is going to get configured, we can use a commissioning devices, and the employee will come and swipes this ID card, and after authentication this trust parameter will be transferred from commissioning device to the field devices. Now, with this approach, employee needs to only swipe his ID card and authenticate the transaction. He does not need to remember a unique secret key for individual devices, and the field device can get this trust information only when the employee has authenticated the transaction. Therefore, any attacker device will not have this information until there is some employee who has transferred the trust from the identity card from the employee management system to these field devices. Now, in the second phase of this framework, we use this initial trust from employee to authenticate whether it can join the network or not. Now, the device has its trust parameter, it generates a nonce and sends a join request to the security management component, and this packet is encrypted with the employee management system public key, and this has been given to the device while the employee has configured the device. Now, security manager can verify with the employee management system whether these trust parameters are authenticated and whether the device has the correct trust value from the employee. With this step, security manager can ensure that the device is configured by an authorized employee. Now, in the third phase of this framework, we do the mutual verification between security management component and the field devices. Now, the security manager has retrieved the nonce value what the device has generated. Now, it will generate another nonce value and increment the nonce of the device. Now, this packet will be sent to the field devices encrypting with the nonce value as a one time key to the field device. Now, with this field device can verify whether the security manager can retrieve the nonce of the device, slave device or not, and it generates another random number and sends back the packet to security manager encrypting with the nonce value of the security manager as one time key. With this step, field device verifies the security manager can retrieve the nonce value of the devices and it has the proper key to decrypt. Similarly, security manager also verifies the authenticity of the field device. Now, in the final stage of this workflow, the key establishment is done, where the security manager will generate the key as per the security policy and sends this key encrypting with the random number as a one time key to the field device. With this key establishment is done without any manual intervention, only the employee swipes the identity card and this key establishment is done automatically from the security manager. Now, the other part of key management like key update and key revoke can be done from the security manager later part, because they are already transmitting the key as a parameter which is encrypted with the random number. Now, this framework also supports like hierarchical trust establishment. If the device does not have direct connectivity with employee management system or the security manager, then other device which has already established the trust with employee management system or security manager can used as a point which can anchor the trust in the field device. With this field device, we will send the join request to the next level of the device. The next level of the device will forward the packet to the security manager and signs with this identity. Therefore, security manager will know that the packet is not replayed one, instead it has come from an authenticated forwarding device. And the same way, with the help of employee management system, the verification is done and the key establishment is completed. Now, let us have a look on the specific contribution in this thesis. We addressed two research questions: bootstrap of initial trust in the industrial devices. We introduced a starting point to support key management, and we verified this security workflow through Avispa tool. Avispa stands for Automated Validation of Internet Security Protocols and Application. Now, with this tool, the security protocol can be written in high level protocol specific language, and the Avispa tool has certain backends which does the analysis of the security protocol. While we write the protocol with the security properties and security objectives, the Avispa tool can run those backends analysis tool and verifies whether it passes the security objectives or not. I have used SPAN, which is security protocol animator, where we can write the protocol in Alice Bob notation and it will generate the high level protocol specific language, and the Avispa will check the security objective. Now, in the second research question was life cycle of the security workflow management. Here we introduced the trust establishment framework and we have done a proof of concept implementation to show that this framework is feasible to implement. Now, let me conclude my talk. We have proposed a framework, it is like secure device framework. We have given a solution for dynamic environment of employee roles. Now, the employee does not need to know the secret key for the devices. Instead, we are binding the knowledge of employee with the field device, and later part of the time, if something goes bad, we can track down which employee has commissioned the device. Now, there is no need of unique secret for the device, which is difficult to manage. It simplifies the key distribution mechanism because employee does not have to enter any secret key there. We propose the mechanism where the device can verify whether it is joining the intended network or not. We have proposed this in hierarchical authentication, where if the device does not have direct connectivity, still with other established trust devices, it can create a chain of trust. Now, through a proof of concept implementation and the security analysis, we show that it is feasible to implement and satisfies the security objectives. We have also identified some of the future work which should be done. One of the interesting future work should be develop a mechanism to verify the device integrity before transferring the employee trust. In current scenario, we are assuming the device is coming from the plant and it does not have any attack inside that, and employee is transferring the trust to the device. Now, before transferring the employee trust to the devices, the device integrity can be verified. So, this we need an investigation and some mechanism to support this. Now, there will be another future work which can detect the compromised device and retain the trust in the network. In current scenario, we are building the chain of trust from the trusted one, and we have not assumed any device which is already compromised or not. Now, probably we need to have a mechanism which can detect if some device is compromised and then how to restore the trust in the network. For this, we need a mechanism to do a runtime security assessment. As of now, we are doing how to bootstrap the initial trust in the network. Once the key establishment is done with the security management component, whether the devices is satisfying the security objective or not, this type of assessment should be done at the later part of the future work as of my thesis. I think with this I close my talk. Thank you all for your attention.
Thank you very much, Apala.
Thank you.
Then let us take a 5-minute technical break while we rearrange for the opponent session.